For decades it was a planet, the ninth world of our solar system, taught in classrooms, drawn in every diagram, and then it was removed, not destroyed, not lost, redefined. A decision that changed how we classify worlds, and forced us to ask a deeper question. What is a planet? This is Pluto. In 1930, Pluto was discovered by Clyde Tombaugh. At the time, astronomers were searching for a mysterious planet X, a body believed to be affecting the orbits of Uranus and Neptune. Pluto appeared to fit. It was distant, faint, moving slowly against background stars. It was classified as the ninth planet. For decades, that classification remained. But there was a problem. Pluto was small, much smaller than expected. Eventually, it became clear. Pluto could not explain the orbital irregularities. And later, those irregularities themselves were re-evaluated. The original reason for Pluto's discovery was no longer valid. But Pluto remained a planet, because nothing challenged that definition. Yet, Pluto does not orbit like the other planets. Its orbit is highly elliptical, strongly tilted. At times, Pluto comes closer to the Sun than Neptune. This is not typical behavior for a planet. Most planets follow relatively flat, circular orbits. Pluto does not. It moves through space differently. This was the first sign that Pluto might not belong in the same category. In the 1990s, astronomers began discovering objects beyond Neptune. Many of them. This region became known as the Kuiper Belt, a vast collection of icy bodies. Pluto was not alone. It was one of many. Some objects were similar in size, others even larger, including Eris. This changed everything. If Pluto was a planet, then should all these objects also be planets? The solar system would suddenly have dozens, possibly hundreds. The definition had to change. In 2006, the International Astronomical Union made a decision. They defined what a planet is. To qualify as a planet, a body must orbit the Sun, be spherical, clear its orbital neighborhood. Pluto meets the first two conditions, but not the third. It shares its orbit with other objects. It does not dominate its region. As a result, Pluto was reclassified, not as a planet, but as a dwarf planet. The decision was controversial, emotional, but scientifically necessary. Pluto did not change. Our understanding did. For decades, Pluto was just a point of light, distant, unresolved, unknown. That changed in 2015. The spacecraft New Horizons performed a flyby. For the first time, Pluto became a world. Not a dot, but a landscape. What it revealed was unexpected. Pluto is not a frozen, inactive object. It is complex, dynamic, geologically diverse. Its surface is not uniform. It contains plains, mountains, and regions of active change. Pluto was not what scientists expected. It was more. One of the most recognizable features is Sputnik Planitia, a vast, heart-shaped region, composed primarily of nitrogen ice. This region is not static. It shows signs of convection. Large cells slowly circulate material. Warm ice rises. Cool ice sinks. This process reshapes the surface over time. Mountains of water ice surround this region. Some rise several kilometers high. At Pluto's temperatures, water ice behaves like rock, while nitrogen ice behaves more like fluid. This creates a landscape unlike anything on Earth. Pluto is cold, but not inactive. Pluto has an atmosphere, but it is extremely thin, composed mostly of nitrogen, with traces of methane and carbon monoxide. This atmosphere is not constant. It expands and contracts depending on Pluto's distance from the Sun. When closer, ice sublimates, turning into gas. When farther, it freezes back onto the surface. This creates a seasonal atmosphere, one that appears and disappears. Observations show multiple haze layers extending high above the surface. These layers scatter light, giving Pluto a faint blue glow. Even here at the edge of the solar system, there is structure. Pluto is not alone. It has moons. The largest is Charon. Charon is so large relative to Pluto that the two form a binary system. They orbit a common center of mass. This center lies outside Pluto itself. This is unusual. Most moons orbit around their planet. Charon and Pluto orbit each other. Their gravitational interaction is strong. They are tidally locked. Each always shows the same face to the other. This creates a stable configuration, a paired system. Not a simple planet-moon relationship, but something more balanced. Pluto did not disappear in 2006. It did not change physically. Only its classification changed. But that change was important. The decision by the International Astronomical Union forced scientists to define what a planet actually is. Before that, the definition was informal. Based on tradition, Pluto exposed the problem. It did not fit cleanly. Too small to dominate its orbit. Too complex to ignore. The reclassification was not about removing Pluto. It was about improving understanding. Science did not reduce Pluto's importance. It clarified it. Pluto is ancient. It formed in the outer regions of the solar system, where conditions remained cold, stable, preserved. Unlike Earth or Mars, Pluto has not undergone large-scale geological recycling. Much of its surface reflects early conditions. Studying Pluto helps scientists understand planet formation, chemical composition, early solar system dynamics. Pluto is not just an object. It is a record, a preserved fragment of the past. Pluto is part of the Kuiper Belt, a region filled with icy bodies beyond Neptune. This region extends far into space, contains thousands, possibly millions, of objects. Pluto is one of the largest, but not unique. Other dwarf planets exist. Eris, Haumea, Make. Studying Pluto provides insight into all of them. It acts as a representative, a sample, a guide. Understanding Pluto helps map an entire region of the solar system. Pluto raised a question that remains unresolved. What defines a planet? The current definition is based on orbital dominance. But some scientists disagree. They argue for alternative definitions, based on physical characteristics or formation history. The debate continues. Pluto remains at the center of that discussion, not as a planet, not just as a dwarf planet, but as a case study, a boundary, a reminder that classification evolves. Science does not stay fixed. It adapts as new data emerges. As understanding deepens, Pluto is no longer the ninth planet, but it is still important.